Welcome to Data Science 1, Probability, Graphical Representation of Probability Distributions. All right, so here are the distributions we're going to look at. So if you haven't looked at these recently, you might want to go back and watch the videos just so you're up to speed on what's going on with them. So we're going to look at the binomial, the geometric, and the Poisson. Okay, so we've been staring at these formulas, and a lot of people don't like to look at formulas, but a lot of people do. So it's not easy to tease out exactly what's going on with the entire distribution of this when you look at a single number at a time. So what we'd like to do is look at all of it at a time, sort of look at it as a whole versus individual values. So we're going to start off with a binomial, and this would read binomial random variable x comes from a binomial experiment with 10 trials and probability of success of 0.3. And here's our formula for it, and we've been loving looking at this. But what if we made a picture of it? And that's the idea here. Let's just make a picture on an xy plane. Here's x, here's the probability of x, and what we do is we just plugged in 0, and we calculated everything. I'm not going to go through all the minor calculations to show you what's going on, but here it is, and we end up with 0.0282. And we plot this on here, and I'm going to put a little line straight up. Okay, and then I'm going to go and plug in 1, and I'm going to do this, and I'm going to get 0.1211, and I plot that again, and continue on with 2, and 3, and you're getting the idea. We plug in the number, we get out a number, and then we're going to plot it on here, and we're going to draw a vertical line that's associated with it. Now, if we go through and do all 10 values, you can see the 10th value is really, really small. I mean, it's not exactly 0, but it's really close to 0. I think it's 6 zeros before your first number, something like that. So here's what the entire distribution looks like, and what this gives us is the ability to really look and see what's going on. For example, how tall the bar is tells us the probability. So this one we can just read over here, but we really don't even need to read it so much as look at them relative to other ones. So look at x3. It has the highest probability, and we can just pick that out. If we looked at the formula alone, we'd be like, I don't know which one that is, and it might be difficult to figure out directly. We can also see that x equals 10 has a very low probability, and hence is very unlikely to happen. Even though it may happen, it's very unlikely to happen. We could look at a geometric experiment. Okay, so this would read that x comes from a geometric experiment with probability of success 0.3. And if we were to plot this picture, this is what we see, and we see it looks very different from the binomial. And notice that this one doesn't have an upper bound on it. So at some point, you just have to give up. You have to say, well, they're all kind of 0 after this point. So we'll just stop there because there's really no point in keep going because every value after that's going to be 0. Now let's look at the Poisson, which is another distribution. Now this one has a little bit of a different flavor to it because it does go up to infinity, essentially. All the countable numbers are usable. All the positive countable numbers, are usable on this. And here we have the distribution here, and we can see, look, it looks like here we have, in terms of them relative to each other, it looks like 3 and 4 have about the same probability. If you stare at that, it looks like they have about the same probability. So they're pretty close to being equally likely, if not exactly equally likely. I'll let you work out the math to see if they are. But this is the picture that we're going to get. And looking at these pictures tells us a lot about what's going on just by reading the picture. And that's the whole idea here, is often a picture, it is often said that a picture's worth 1,000 words. And in this case, it absolutely is. You can get a lot of information from this picture about the distribution as a whole, and that gives you a sense of what happens in the experiment, right? We're going to most likely measure 3 or 4 on this type of experiment in this case. We're not going to see a 15 very often. We might see a 15, but it's not very likely. And we might see a 0, and it's got a reasonable height to it, which means there's a decent probability that that would actually occur. So learning how to read these is very, very useful. The other thing you want to look at is them relative to each other. Look at how much higher this one is than this one. So 0 is down here, 1 is a big jump. in probability, and that relative probability is often really important to look at. Where out here, if we go up by 1, the probability isn't really changing much, but if we go from 0 to 1, there's a huge jump, and from 1 to 2, there's a huge jump, and from 3 to, looks like, or 4 to 5, there's a decrease. And so we get lots of information about these just by looking at the picture. All right, so here's a quick summary. Graphical representations allow us to understand the probabilities better. Instead of looking at individual values, we look at the whole thing, and then we can look and say, well, which value is most likely? Which values are least likely? They can tell us which values are more likely than others. And it gives us an idea really what's going on in our experiment. And it's easier to understand what outcomes may or may not occur from our experiment. So if we're expecting something, then we can see whether that matches what we thought should happen versus what actually happens. And that's sort of where statistical inference begins. But we'll talk about that more later. All right, so we'll move on to the next video and see you there.